our agenda for the webinar is what is mobile application security, understanding the threats to mobile applications, what is new in OWASP top 10 mobile, and then we'll have a small questionnaire where you can ask your queries, and then we'll be concluding the session. Now, the very first thing is when we are talking about mobile application security, first term we can see is mobile application. Now, what is mobile? Something that's convenient, which is handy to like if you are traveling and you can take it with yourself, right? So there are billions of users worldwide and millions of applications available across Google and Apple digital markets, right? So smartphones, they have become a commonplace for us, right? The difference they make to our lives, it's simple and stark also, and it's impacting our day-to-day life in multiple ways. So in particular, the way we interact with, the way we work, the way we socialize, right? The increase in demand from consumer market and processing, the power and the capabilities of smartphones like storage, GPS, cameras, displays, they have changed the paradigm of the development of mobile applications, right? So when we are talking about these mobile applications, so the mobile application development, that is the hottest type of software development right now, right? And new surface area equals danger surface area. It means that the uppermost layer of smartphones is mobile apps, which are potential targets of the attackers, right? So we'll have to understand the need of mobile application security, mobile application pen testing, right? Now, so we have three types of applications, broadly categorized, right? We have native apps, right? Now, when we talk about native applications, right, what are those? Native applications are those which reside in the mobile operating systems and they are pushed, or we can say installed through the respective app stores, right? And these apps, they are typically built using development tools and languages like Xcode, Objective-C, Swift for iOS apps, and Android Studio and Java for Android apps, right? And they are designed for a particular platform, and they can take advantage of all the device features, like they can use camera, they can use GPS, phone contactless, so on, right? So you might have heard about a game like there was a game very long back, it was Temple Run, right? That is an example of native application, right? Then we have mobile web apps. Now when we are talking about mobile web apps, these are non-native applications, and most of them, they are HTML5, right? Or JavaScript or CSS applications with a web interface supporting the native application look and feel. So users, they first access them as they would access any other web page, and these are mobile optimized web pages, right? So these applications became popular when HTML5 came around and people started to utilize the functionality of native applications from the browsers, right? And the development and testing of these applications are easy because they all have the tooling support, right? You might have seen the bank applications. So those are what kind of applications? Mobile web apps, right? The apps, Mr. Joseph, that you download from the websites, it depends. Nowadays, those are the third types, like they can be hybrid apps, right? So the third type of application type that we have is hybrid apps, right? Now, when we are talking about hybrid apps, they have, I'll say that it has two definitions. One definition is it is a combination of web-based content and native components accessing the services on the mobile device, storing or using the storage. Another definition is it's of a client server architecture of mobile application, right? So these, like you might have heard about mobile enterprise applications, right? Like there is a application with the name car driver, right? So that's an hybrid app. So these are the web apps which are built into native mobile framework, and they take advantage of cross compatibility of web technologies like HTML, JavaScript, CSS, right? So those are hybrid applications, right? So those are the different types of applications that we have. Now, when we talk about the security, so before the security of the application, you should know that what vulnerabilities can be there, right? So when we talk about the vulnerabilities of mobile applications, there can be many vulnerabilities, like there can be insecure transmission of data, right? When we are talking about insecure transmission of data, it means that either the application does not enforce any kind of encryption. Now, I have taken a name, the word encryption. What does that mean? So, what we are doing, encryption means that we are converting the data into a format which is unreadable. Even if I'm sending some data from my device and someone in between is intercepting that data, should not be able to understand that what data it is, what is written, right? That's encryption. So, if the application is not enforcing any kind of encryption for the data in transit, right? Or the encryption which is implemented in the application, it is insecure. That means it is insecure transmission of data, right? Then there can be problems related to insecure data storage, right? Now, data storage means that you are storing the data in either plain text, right? So there are applications which store the data in a plain text, or or like there are hard coded keys in the mobile device, right? So let's say there is a email exchange server, right? Now there is a configuration on an Android device for an email exchange server using the email client, and it stores the username and password in plain text format. So it is easy to reverse by the attacker if the device is rooted, right? So I will like download the application, I will reverse that application, and I'll be able to get that information, right? Whatever information the application is storing, right? Then many of the applications, they don't have binary protections. What do you understand by binary protection? So the thing is that if there is no binary protection, that means attacker can easily reverse the application, right? So anti-reversing techniques are not enforced, right? Anti-debugging techniques are not enforced. So attacker can put the application in the debugger, run it, and find out that what things are there, right? How it's working, what is the code of the application, how step by step things are going on, everything, right? So that's binary protection, right? Then there are many times client side vulnerabilities, right? Now, client side vulnerabilities means the applications, they do not sanitize the data which is provided by the client side, and it leads to multiple client side injection attacks like cross site scripting or JavaScript injection and so on, right? Many attacks can happen, right? Then, as we discussed, that there can be hard coded keys or hard coded passwords can also be there, right? That means applications are designed in such a way that hard coded passwords or private keys are stored on the device. So attacker will be able to get those keys, right? Then many times it has been found that there was a leakage vulnerabilities, right? Leakage means leakage of private information. So applications, they unintentionally leak private information, right? And it could be the use of particular framework and obscurity assumptions by the developers, right? So leakage vulnerabilities can also be there, right? So you might have heard that there are lots of vulnerabilities in like many applications. Every time there are many applications, they are found, like if you read reports from different researchers, so they always research about the new vulnerabilities, and they tell that how the vulnerability is affecting, right? Even if you have heard, like easiest of vulnerabilities are there, that if there is a like phone, right? So it was Google Pixel 7, if you have heard. So in Google Pixel 7, what happened, that you were able to bypass the lock screen easily. How to do that? You will just basically put a PUC code, right? Back in the old days, like many times our SIM gets logged, right? There was PIN code and then there was PUC code, right? So if you have put the PUC code, enter the PUC code incorrect thrice, twice, and then enter the correct PUC code. The security of that Google Pixel 7 device was bypassed. And this small vulnerability, like not it was not small vulnerability, impact was higher, but easy to exploit vulnerability. The person who found the vulnerability got $70,000 as the bounty to find this vulnerability, right? So that's why we need mobile application security, right? Now, when we are talking about mobile application security, what it is, mobile applications, they put the security and privacy of an individual or any corporation at risk, right? So with more vulnerabilities attributed to your mobile application flaws than any other category today, security has become a concern for the business, right? Many of the attacks have happened. uh, they are associated with the way mobile apps are used and specific methods the application uses to communicate with the user, right? Now, when we talk about mobile applications, so mobile applications, they can communicate with various services, right? And which increase the attack surface significantly, right? Now, what is attack surface? I used a word here in my statement, attack surface. What is that? So, attack surface means all the points where attacker can attack, right? So let's take an example. You have an IoT device. Let's say you have a smartwatch, right? Now, when you have a smartwatch, you have installed an application for that smartwatch inside your mobile phone, right? So if I have to attack, right, there will be multiple attack surfaces. I can perform network based attacks because your data is going from your device, your smartwatch to your mobile phone, right? Then it's not getting stored in your mobile phone, right? Let's say you lost your mobile phone, next day you purchased a new mobile phone. What will happen? You will purchase a new mobile phone, then you will install the same application, and whatever data was there, that data is back, right? Why it is back? Because the data was being stored somewhere else, and that somewhere else is cloud. So I can do cloud based attacks. Then you have installed an application in your mobile phone, so I can do application based attacks, right? So these are what all these are your entry points from where the attacker can start the attack. This is the attack surface. That's how you find out the attack surface, right? So, mobile application security, it refers to the technologies and security procedures that protect mobile applications against cyber attacks and data theft, right? Now, there are two primary impacts of mobile application security. Whenever you are sending data, it's like either it is like data at rest or data in motion, right? When we talk about data at rest, so mobile phones are unique in the sense they reside on users phone, right? And there are threats to these threats to these devices, and they are from mobile malware or other applications. So mobile devices, they are easily susceptible to theft, getting lost, or being acquired by or used by someone else, right? So mobile app developers, they should also consider the possibility of data recovery using forensics techniques, right? Then there is data in motion, right? So sensitive information disclosure or MITM, man in the middle attack, right? These types of attacks are possible when data is not secured in transit, right? Then what else mobile app developers should uh, consider? So they should consider the implications of malicious applications when they are installed from various non-standard app stores. So there are third-party app stores from where you download the applications and then they are installed and you install it in your mobile phone and you are not aware that it is a malware or what, right? So developers, they will always have the war game with latest improvements in mobile malwares, right? So you have heard about Zeus, Zeus Mitmo, right? Then there is Spitmo, right? So these are what? These are the types of malwares which have bypassed plenty of mobile security features, right? That's why we need mobile application security. Then, for providing the security to the mobile applications, don't you think that we need to perform the pen testing of mobile applications? Now, first thing that we should know is what is pen testing. So, when we are talking about pen testing, it is short for penetration testing, and this is the ethical way of finding out the vulnerabilities. The people who perform pen testing are called pen testers, right? So what they do, they act as an attacker. They try to perform the attack on different applications, and after performing the attack on different applications, they will find out that if there is a vulnerability. If they find out the vulnerability, they will report that vulnerability to the higher management. They will create a report of it, and then the vulnerability will be fixed. Right. So before the attacker can find out any vulnerability, pen testers they try to find out the vulnerability first, right? Now, as I said, that there is a need of penetration testing. So mobile apps, they have complex security landscapes. Vulnerability, it may occur due to various reasons, like from misconfiguration, or there can be code level bugs, right? So as the need for mobile applications is increasing, multiple companies, like ranging from, you can say, Fortune 500 to startups, they are investing a lot of money on security programs to protect critical information that is handy for every single individual at their fingertip, right? And the companies intend the application to be secured. So their goal is to identify the loopholes while battling cyber attackers and prevent a serious data breach. So, pen test is one of the most effective ways to identify known and unknown weaknesses and functionality bugs in these applications. And by attempting to bypass security controls and security mechanisms, a security tester is able to identify in which a hacker might be able to compromise an organization's security, and it leads to damaging the image of an organization that they have built over a period of time while building the trust. So that's why we do pen testing, right? Perfect. Now, when we are talking about the threats to mobile applications, so there can be many threats to mobile applications, right? It can be malware infecting the security breaches, right? So attackers they can send malwares, yes, to your device, and when you are sending the malwares, then what will happen? Credential theft can happen. It can bypass the two-factor authentication in your device which you have implemented, right? Then, as we discussed, insecure data storage. So your device or your application is not storing data properly. It's not providing the security in the place where they have stored the data. So database security is not present. So that can be a threat, right? Then malicious third-party code. Now here, malicious third-party code means, let's say, you have an application installed in your mobile phone, right? Now, when you have that application, so that application is basically having some, let's say, updates, right? Now, me being an attacker, I'm releasing an update for that application, right? And when I'm releasing the update for that application, I sent you that update, you install that update, and the application is updated. Though it should not happen, but the developer has not provided security for that. Let's say the developer has not done uh, like any has not written the code that check the hash of the update which is arriving, match it with the compare it with the hash which is for the application which is already installed in your device, right? So that can be the reason. Then rooting or jailbreaking. When we are talking about rooting or jailbreaking, right, it means that taking the actual access of your mobile phone. Right now, when you are using your mobile phone, there are certain applications that you cannot uninstall. Why? Because you are not the root user of your mobile phone, right? You are a normal user of your mobile phone. But if I do rooting, right, if I break those barriers which are given by the secure vendor of the mobile phone, right, then I will become the root user and I can make any changes whatever I want, right? So what we have, rooting is basically a word which we use to gain the root privileges of or super user privileges of the mobile phone, and rooting is done in Androids, we call it rooting. In iOS we call it jailbreaking, right? So rooting or jailbreaking should not happen, right? If you see nowadays, like back in the old days around uh, like when it was Android 5, Android 6, right? At those times we used to root the mobile phone very easily, right? There were softwares like you just connect your mobile phone to to your computer, and then you install an application, Kingo root in your computer and run that, and it will break the security barrier and you will become the root user, right? You just have to press like the lock key and you have to go to the safe boot mode and it will break those barriers, right? But nowadays what is happening, it's becoming difficult to root the mobile phones, right? So for rooting nowadays, if I do like rooting of an any Android, right, any Android device, so for that I'll be just finding out the image of that Android device, right? That operating system I will find out. I will flash that operating system into the mobile phone. So I'll have to crack it, then flash it directly in the Android device, and then it will be rooted, right? Same on the other hand, when we talk about jailbreaking in iOS, now the devices cannot be fully jailbreaked. It's only half jailbreaked. So in jailbreaking, what you do, you install like you have lots of softwares like the one I use is Palrin, right? Or Checkerin, right? Those are the softwares that I use for jailbreaking. And what they do, they will jailbreak your device, your iOS device, and then they will install some repositories from where you can download the third party applications, right? So Celio is there, it will install either Celio or it will install Cydia inside your mobile phone. Then you can open that Cydia store or Celio store, and then you can install any command, any application. Let's say you are installing OpenSSH server, right? Or you are installing ls command or any commands, right? Or you are installing SSL to switch or SSL to kill, right? Those are different applications which are used while performing the pen test. So you are doing that, right? So there should be no rooting and jailbreaking. Now this cannot happen, right? There is always a way to jailbreak or root a device. So what the application developers can do, they can build mechanisms, they still build those mechanisms for root detection, right? So root detection means that if there is an application, I install that application for testing in, let's say, Android device. So what will happen to that application? It You will start the application and it will detect that mobile phone is rooted, so it will terminate. It will not open, right? So that is root detection. If you root a device and if you install Google Play or Google Pay in that, and it will open. When you enter the number, it will give you an error that you cannot run Google Pay because it is rooted, right? So these types of mechanisms should be there. Though there is a way of bypassing the jailbreak detection and root detection, but these things should be there. Then the authentication procedures that we are using. See, the thing is that we have simulators for mobile pen testing, right? Either you use Android Studio for Androids or you use Genymotion, right? But the thing is that when we try to install certificates and when we try to bypass the security, so things become different when you are working in a simulator and when you are working with uh, a real device. Same like that, you have like a best simulator for iOS I have used is Corellium, right? But Corellium is paid and it's around $100 a month, right? But it's good. You can get like unjailbreak device also, jailbreak devices also, Android devices also in Corellium you can get, right? But still, if you work with the real device, things will be bit different. The path of the things, the way of doing things will be bit different, right? So I'll suggest that for learning, use simulators, but for practicing and doing real world pen testing, we should use real devices. When you are a developer, you should make sure that your device has written your application has a piece of code which is detecting if the device is rooted or not, or jailbreaked or not. If it is rooted or jailbreak, then your application should terminate quickly. It should not work, right? Then authentication procedures. So the authentication procedure may make it simple, right? Passwordless authentication should be there, right? Or multi-factor authentication should be there, or you can use single sign-on, right? So these are the ways. Then client-side injection can be there, right? So malicious code can be executed, and then like you can get affected with that, right? So for preventing that, you can use input validation, or there should be parameterized queries that you can check that what the user is entering, what the user is trying to do, right? All those things you should know, right? Then we have weak server side controls, so man in the middle attacks can happen, like we have not implemented encryption, right? So strong server side control should be there, end to end encryption should be there, right? Insecure transport layer protection, so you are not using HTTPS protocols, right? So you have to implement the encryption properly. Regularly you have to update the security certificates of your application, right? Then nowadays it's going on a lot, deepfake technology like impersonating as someone else and phishing attacks. So if you are like, let's say you have copied, if you guys know about chat GPT, right? Everyone might have uh, known the chat GPT, right? So chat GPT works on a model GPT, right? And that model I used many years back. Like last time I used that model, it was around 2014 or so, right? So at that time also, what was happening, that GPT model was doing great. And after that, it was found, and this like for security purposes, it was told to all the users that whenever you are uploading your pictures on social media or anything, so you should not keep your hands in the ear, or your hand should not be visible fully, because this model did what, a security researcher, he found that using this model, he extracted the fingerprints of the person in the image, and he used those uh, fingerprints to unlock the mobile phone, and mobile phone was unlocked, right? So that much effect this deepfake technology can do, right? Then app permissions. So you should look for app permissions. The app permissions should be proper, right? If your application is able to access unauthorized locations or call logs or cameras or contact files, that's, and even if it does not need it, that's a problem, right? So you have to make sure all these things are not there. These are some of the threats that are there for the mobile applications, right? Now, for these threats, we have something with the name OWASP Top 10, right? Now, when we are talking about OWASP Top 10, OWASP stands for Open Web Application Security Projects, right? This is an organization which was created in 2001, and this organization provides you the top 10 attacks or vulnerabilities which are there used by the attackers more frequently, right? So last time it was in 2016 they released a list for mobile applications, and now recently they have released a list for the mobile applications, right? Now there, as I said, that you have OS top 10, right? So in this they have given 10 vulnerabilities. Now these 10 vulnerabilities that we have, right? So what they have like before it was improper platform usage at the first place, right? Now it is improper credential usage, right? Now what is improper credential usage? Improper credential usage means you're not either checking the user ID and login ID and password, or attacker is able to put anything in the place of login, or you are not authenticating properly, or you are not storing the things properly, right? That's improper credential usage, right? Then inadequate supply chain security, like if you are if that application is connected to some other application, right? That can be a problem, right? So supply chain attacks can happen, right? So if that application is connected to any cloud, and that cloud provider got compromised, so your application and all the users who are using that application may get compromised, so that's a problem, right? So these two are new. Then insecure authentication and authorization, that means you're not properly working with the multi-factor authentication or two-factor authentication, and you have not given proper access controls. So we have to make sure that we have given proper permissions to our applications, right? That what things application will be able to access, what places it will be able to access, what places not, right? Then insufficient input output validation, what that can be. Now insufficient input output validation means that you are not validating that what input the user is giving. Maybe there is a login page and I'm giving the input as single quote or single quote 1 equals to 1, right? In both the username and password field. This is an SQL injection query, right? So I will be logged in if the application is not doing input validation, right? So the thing is that this SQL injection query, it's a universally true condition. Now this universally true condition, it will be basically checking, right? That if the application is accepting a universally true condition. So whenever you send anything true to the application, application replies back true and it will log you in, right? That should be checked. Then insecure communication. So it was in on M3 and now it's send to M5, right? Usage is less, but it's not removed. Now, insecure communication means your communication protocols, they are lacking the things like encryption, like SSL or TLS certificates you are not using, right? You are not using digital certificates for communication. So it's missing that, right? Then next we have is inadequate privacy controls. Now, when we are talking about inadequate privacy controls, it means that your data does not have any privacy, right? Your application is able to interfere with any other application's data and your own personal information also. Like if you are in India, you have used Truecaller a lot, on an application which tells who is calling. If the number is unknown, it will give you a name that this is the name of this person who is calling you. That application was taking a lot and lot of data from your device. Even it was taking the your government IDs information, right? And when it was leaked, so lots of people and their information was leaked, right? So inadequate privacy controls are there. Then, as we discussed about binary protections, right? So we have inadequate binary protections. What is that? It will expose the application and its owner to a lot of technical and business risk, right? So it like a lack of binary protection, it results in a mobile app that can be analyzed, reverse engineered, or modified by the attacker, right? An application with the binary protection can still be reversed by the dedicated attacker, and therefore binary protection is not a perfect security solution. But binary protection, it only slows down a security review, right? So it's extremely common for applications to be deployed without binary protection, and it's studied by a large number of security vendors and researchers that they are not people are not they are not applying binary protection to their applications, right? Then there can be security misconfigurations. Now, when we talk about security misconfiguration, it means that like before it was called extraneous functionality. So what attacker can do, attacker looks to understand this security misconfiguration within a mobile app to discover hidden functionality in the backend system. So attacker will download and examine the mobile application with their own local environment, and they will examine the log files, configuration files, and binary to discover any hidden switches or test code that was left behind by the developers, right? And they will exploit the hidden functionality in the backend system to attack, right? So that's why you have to make sure that you are not leaving any footprints behind, right? Then, correct, disable debugging. So the attacker is not able to understand the working of the application stepwise, and maybe the attacker will not be able to find anything in the application, right? Then insecure data storage. So it was on M2 second position. Now it moved to position 9. And insecure data storage means that you are not storing the data properly. Wherever you are storing the data, it's uh, basically insecure place, no encryption, right? So when the development teams, they assume that user or malware will not have access to mobile device file system or any sensitive information on the device, then these vulnerabilities occur, right? File system, they are easily accessible. So organizations, they should expect a malicious user or malware to inspect sensitive data stores, right? So if you are using poor encryption libraries, that should be avoided, right? Rooting or jailbreaking a mobile device, it bypasses all the encryption protections, right? So that should be taken care by the developers, right? Then there is insufficient cryptography. Now, insufficient cryptography means the same thing, right? So attackers, they correspond to the same attack vectors which are available through the traditional OWASP top 10, right? So in order to exploit this weakness, attacker must successfully return encrypted code or sensitive data to its original unencrypted form due to weak encryption algorithms or any flaw in the encryption process, right? So this was the change in the OWASP top 10. This is the new OWASP top 10 which has arrived, right?